Hi there, hope you are doing fine. This is Mr. Philip Koma, the excellent biology tutor. This is part 2 and we're looking at excretion. Without wasting much of your time, let us begin. So what are the objectives of this video? What are we going to learn after we are done with this video? We're going to look at the structure of a nephron. Then finally, we're going to look at how the kidney functions. These are the things that we're going to look at in this tutorial video. Alright. So in our previous video we looked at the kidneys. We already know the function of the kidney. It's the one which is responsible for excreting urea, excess salts and excess water. I hope you haven't yet forgotten. Again, we defined what excretion is, we defined what excretory organs are, we defined what excretory products are. So today we're going to advance to something new. Okay, this is the structure of a nephron. So the nephron is simply the basic functional unit of a kidney. It's like a cell. It's a basic functional unit. A collection of these nephrons, they will form a kidney. Okay, so it is in the nephron where the excretion occurs. So the nephron is the basic functional unit of the kidney, and it looks like this. Beautiful diagram, if you ask me. This is a beautiful diagram. So let's just look at it for a minute. If you can pause the video and look at each part. So as you can see, we've got blood flow. So blood is entering from this at this point. So this is a blood vessel. Well, as long as there's blood flow, that's a blood vessel. Okay, no two ways about it. So what we can see in gray is a blood vessel. It's a blood vessel. So blood is entering from this point. As you can see, it's entering, then it comes out from this point. Then we've got another tube. Okay, we've got another tube. So blood flow. All right, then we've got the afferent end, then we've got the efferent end, then we've got the glomerulus. This is the glomerulus. It's the glomerulus. And then we've got the Bowman's capsule. So this is the Bowman's capsule. Then there's this entanglement which is happening here. This is known as the first proximal covulated tubule. And then here we've got the loop of Henle. Then we've got another entanglement which is the second distal or distal convoluted tubule. And then we've got the collecting duct, and blood is coming out from those ends. So this is what we have, and this is the structure of the nephron. Please pay attention to this diagram. Know this diagram. Okay, this is the diagram of the nephron. Alright, now excretion in the kidneys occurs in stages, and that's my focus in this video. We're going to look at the stages, okay, the stages of excretion in the kidneys. Okay, it occurs in stages. The first stage is known as ultrafiltration. Ultrafiltration. So what is ultrafiltration? This is the filtration of small molecules such as water, mineral salts, glucose and urea from the glomerulus into the Bowman's capsule of a nephron. So filtration, what does it mean to filter? In chemistry, you're going to learn that there is what they call filter paper, which is used to carry out filtration. So so if you have dirty water, let's say you get clean water, you mix it with sand, all right, then you get a filter paper. That filter paper, let me try to illustrate using a diagram, though I'm using a mouse, so bear with me. Let's say this is a beaker, right? This is our beaker. A filter paper is placed on top of this is a kafanel. On this same funnel, we put a filter paper. In filter paper, it's going to filter out the small molecules. So you're going to get that mixture of water and dirt. You start pouring up. You'll find that only clean water will be penetrating. Only clean water will be filtered. That's filtration. Okay? So only small molecules are penetrating through this filter paper. Manzi zambo donya oku to clean to manzi, and then the dirt will remain up as residue. Are you following? Yes. So now that's what happens up glomerulus up. That's what happens. Let me just zoom because you need to see. So that filtration occurs up. And what is filtered at this point is small molecules of what? Water, mineral salts, urea, glucose. Those are the things that are filtered. When they are filtered, they will go into the Bowman's capsule. That's where they will go. The mineral salts, the water, the urea, they will go up. Bowman's capsule. So let me just erase this. Just give me a minute. Let me erase it. Okay. So this is the filtration of small molecules such as water, mineral salts, glucose, and urea from the glomerulus into the Bowman's capsule of a nephron. It is caused by a buildup of pressure in the glomerulus. Buildup of pressure. So there is pressure that is built in the glomerulus, and this pressure builds up due to the following reasons. Number one, the afferent end of the glomerulus is wider than the efferent end. So there's pressure that is going to build up in the glomerulus, and that is because the afferent end is wider than the efferent end. So there will be a lot of blood entering, and since this part is narrow, it will take some time for that blood, to go, because the efferent end is narrow. Understand? Ukukuli wide, so there will be a lot of blood coming in, a lot of blood to be flowing, but it will take some time for it to pass because this part is now narrow. The afferent end is wider than the efferent end, meaning the efferent end is narrow. Okay, so it will take some time, blood will take some time pamene up. As it is here, filtration will start taking place. Okay, so that's one of the reasons why which builds up the pressure which is in the glomerulus. Another one, blood from the arteries is under high pressure. The arteries, they transport blood under high pressure, my students. If you look at transport in animals, that is stated. Arteries, they transport blood under what? Under high pressure. Yeah, that's one of the characteristics. So those are the two reasons why there is a build-up of pressure in the glomerulus. Now, during ultrafiltration, the red blood cells and large molecules such as plasma proteins remain inside the glomerulus. Okay, the liquid that collects in the Bowman's capsule is called the glomerular filtrate. The glomerular filtrate is drained from the Bowman's capsule by the renal tube. So bakamba chani hapa, large molecules such as plasma proteins, they will remain in the glomerulus because only small molecules will pass through. Only small molecules are filtered. Small molecules like water, mineral salts, glucose, and urea, those are filtered. They will go into the Bowman's capsule. But large molecules won't be filtered. Okay, they are going to remain in the glomerulus. Large molecules like what? Those of plasma proteins. So the urea, the water, the mineral salts, and the glucose that are filtered will drain. They will drain into the renal tube. They will drain ezangino. Okay, the water, the mineral salts, the glucose, the urea, that will drain into the renal tube ezangino. Just like that. Are you following? Okay, I am glad you are following. So let's continue. We're still learning. So those are the events that occur under ultrafiltration. So during the stage of ultrafiltration, small molecules are filtered. What are those molecules? We've got we've got mineral salts, we've got glucose, we've got urea, we've got water. Those things are what? They are filtered because they are small molecules. Large molecules such as proteins are not filtered. Following what? Large molecules are not filtered. So if they ask you an example, give an example of large molecules that are not filtered, you already know. Proteins, plasma proteins. Alright. Now the next stage is selective reabsorption. So what is selective reabsorption? This is the reabsorption of useful substances from the glomerular filtrate into the renal tubule into the bloodstream. Let me read that again. This is the reabsorption of useful substances from the glomerular filtrate in the renal tubule into the bloodstream. It occurs mainly in the folded regions or convolutions of the tubule, where the tubule is entangled with blood vessels to facilitate reabsorption. Let me pause there. Let me pause there and explain. Let me pause there and explain a bit. So, upper filtration is taking place. What is filtered? Water, mineral salts, urea, glucose. They are filtered, and then they will drain going into the Bowman's capsule. They will go into the Bowman's capsule. They will drain into the Bowman's capsule. Now, that mixture, there is what? Water. There is what? Mineral salts. What else? Glucose. What else? Urea. Right? There are useful substances in that mixture. Not everything is bad. Okay? Urea, glucose, mineral salts, water. Among these, not everything is bad. What is important is reabsorbed into the bloodstream. And the reabsorption of useful substances occurs up, entanglement up. That's where the reabsorption occurs. At this point and this point. That's where the reabsorption occurs. Are you following? So, let me read that again. It occurs mainly in the folded regions or convolutions of the tubule, where the tubule is entangled with blood vessels to facilitate reabsorption. So the reabsorption of useful substances occurs up, permanently entangled up. Okay? So the first proximal convolution reabsorbs all glucose. So remember, glucose is part of the glomerular filtrate, which is filtered here, right? So glucose is reabsorbed up. All glucose is reabsorbed. Some water and some salts. So upper, all glucose is reabsorbed. What else? Some water. What else? Some salts. Not all of it. Not all of the water, not all of the salts, but all of the glucose. So all of the glucose is reabsorbed at the first proximal. Some water is also reabsorbed and some salts. Are you following? Yeah. The second convolution reabsorbs salts and water up. The second convolution reabsorbs salts and water. So let me pause there. What is the glomerular filtrate made up of? It's made up of urea, mineral salts, glucose, water. What is useful? Mineral salts, glucose, water. What is being excreted? What is not useful for the body? Urea. So as you can see, urea is not reabsorbed at any of these 2 points. It's not reabsorbed because it's not useful. Only useful substances are reabsorbed, like glucose, like water, like mineral salts. These are useful substances, like the definition is saying. This is the reabsorption of useful substances. So these are the useful substances that are reabsorbed. Mineral salts, water, and what else? Glucose. So per first proximal, all glucose is reabsorbed, some water and some salts. Per second proximal, water is reabsorbed, salts are also reabsorbed. Now, water is reabsorbed by osmosis, and I'm sure by now we know what osmosis is. I won't even talk about that. Water is reabsorbed by osmosis, glucose by diffusion, and mineral salts by active transport. I know that you know what these terms are. You know what osmosis is, you know what glucose is, you know what diffusion is, you also know what active transport is. So water is reabsorbed by the process of osmosis, glucose by the process of diffusion, and mineral salts by the process of active transport. So remember, first proximal, all glucose is reabsorbed, some water, some salts. Upper, only salts and water. Alright. What's the other stage? Osmoregulation. Osmoregulation. What is osmoregulation? So this is the regulation of water levels in body fluids. The regulation, the control of water levels in body fluids. Osmoregulation takes place in the loop of Henle. That's where osmoregulation occurs. The loop of Henle. if the body has little water in it, a hormone called antidiuretic hormone, which is ADH, also called vasopressin, is secreted by the pituitary gland in the brain. When we look at hormones, we're also going to talk about this. That's the beauty of biology. These things are repeated, okay? So if the body has little water, there will be a hormone that is going to be secreted. What hormones do is that they stimulate an event to take place. To stimulate simply means more like kupasa chimwela, like to cause something to happen, to stimulate, to cause something to happen. So when the water levels are low in the body, there will be a hormone that is going to be secreted, known as the antidiuretic hormone, ADH, also called vasopressin. This hormone is secreted or released by the pituitary gland, which is located in the brain. So this hormone will cause water, it causes water to be absorbed from the glomerular filtrate into the surrounding cells. It will cause your body to absorb the water from the glomerular filtrate. Remember the glomerular filtrate? I'll repeat. When blood is flowing, small molecules are going to be filtered. What are those molecules? Mineral salts, water, glucose, urea. So these four, they will form the glomerular filtrate, which will now be in the Bowman's capsule, and then it will drain. So from that glomerular filtrate, water is there. So when water levels are low, there will be an absorption of water from the glomerular filtrate. I'm sure I'm there. Okay, so it causes water to be absorbed from the glomerular filtrate into the surrounding cells. That's what that hormone does, ADH. This results in the production of small volumes of concentrated urine. By that it means depaja pamene timatunda mitundo za brown zizoneka mungani tea. Okay, just know that manzi mtupi siali enough. Understand? So the urine will be concentrated. But if the body has enough water, ADH is not secreted and huge volumes of dilute urine are produced. So ngati tupi ilibe manzi, ADH is produced. ADH yemenewetana kuti antidiuretic hormone. ADH, it is secreted by the pituitary gland. Now, chito ya ADH ni chani? It will cause your body to absorb, okay? It causes water to be absorbed from the glomerular filtrate into the surrounding cells. Glomerular filtrate ni chani? It is simply the filtration of water, mineral salts, glucose, and urea. So from that, water is going to be absorbed when water levels are low. And in such situations, you find that an individual will pass out concentrated urine. But if the body has enough water, ADH is not secreted and huge volumes of dilute urine are produced. So remember, everything occurs party loop of Heno. Alright, my students, let's look at the final stage. Secretion. Secretion is another stage. Secretion. What is it? What is secretion? So secretion is the removal of urine from the kidney through the collecting duct and ureter. Urine is a mixture of urea, excess salts, and excess water. The urine is passed on to the urinary bladder where it is temporarily stored before being passed out. So secretion is the removal of urine. Okay, it's the removal of urine. It's now secreted. It's the removal of urine from the kidney through the collecting duct and ureter. On a collecting duct, it will collect the urine is in the manch. It will go to the ureter, then from and then the ureter will carry it, taking it to the bladder to be stored. Okay? Yeah. So my students, Kwasir, that's how the kidney functions. I've explained the stages of the stages of excretion in the kidneys. The first one is what? What's the first one? The first one is ultrafiltration, where small molecules are filtered, forming glomerular filtrate. The other one is what? Selective reabsorption, which occurs from proximal, first proximal, and then the second proximal. And then the other one is osmoregulation, then the final secretion. Watch this video again, go through the notes, and try out the questions that are sent to you. Alright, this is Mr. Philip Koma, the excellent biology tutor. Please leave a like for this tutorial video. If possible, even leave a comment for your sir. I will really appreciate. If you haven't yet subscribed, please do so. Alright, stay blessed.